in it. But I'm going to now, as soon as I can, remove the need for using this word methodology, and I'm going to describe methodology in a different way from an engineering perspective. So I'm going to look at what do we mean by method and methodology, and I'm going to be able to throw out both the words method and methodology and replace them with something that's a lot more closer to home in engineering. But before we get to that, we need a story. Now, you saw last time that we had the story of the knowledge land, and this time I've got another story. There's no dragons or monsters in the story. The monster is only right at the end of this webinar, but we're going to have a story. And the story that we're going to work with is a first-year engineering student, and that might be scary enough. But we're going to be working with a first-year engineering student, and this first-year engineering student has been tasked with the following. The student has been tasked with making an orthogonal translation rotational energy transfer device. Okay, so now that's an interesting looking title. It's just as interesting looking and as incomprehensible as some people's research titles. We battle to make sense out of that. But in any case, it's very nice and cryptic. But the student, this first year student that's been tasked with this in one of his courses, the student is a really good student, and they come up with a good solution. They are able to tell us something about this orthogonal translational rotation energy transfer device. And they show us, okay, they show us the following. Right, there it is. Cool. What do we see? We see over here a bunch of parts. I'm seeing parts that I might recognize. Here I see a gear and another gear, and I'm seeing some kind of rod things. And down over here, I'm seeing a screwdriver, and I'm seeing what looks like a spanner. And then I'm seeing a whole lot of bits and pieces of steel. And in the middle here, I'm seeing what might look like some bolts and nuts. Okay, so I'm seeing what this first year student is showing me. And I now look at this title, which says Orthogonal Translation Rotational Energy Transfer Device. And I look at this picture, and okay, I'm a bit confused. It looks a bit confusing. I can claim here with certainty that I don't understand. Now, if you are a mechanical engineer and you can make sense out of all of these terms, you might already in your mind be able to think what is possibly going on here. But for that, you need to be a pretty big expert. And I'm not the expert, so I claim I don't understand what's going on here. Right, so I tell this first year student I don't know what's going on, and the first year student then shows me something else. Right, so the first year student is now showing me this. And again, I'm looking at the title, Orthogonal Translation Rotational Energy Transfer Device, and I look at this thing over here, and immediately I see there's a crank over here on the one side, and there's a shaft linking a gear, and at 90 degrees there's another gear, and there's another shaft also at 90 degrees. So now I'm really thinking, yeah, orthogonal, so 90 degrees, that it's a translation, sure. So that I had a rotation in one direction here, and I got a rotation in another direction there. And I'm thinking I can transfer energy across this device. And over here, out on the right-hand side, I can see a close-up of what those gears are doing. And all of a sudden, I can say that these pictures make sense in relation to this title that I've been given. So I can sort of claim I understand. Now let's look at these two pictures together. Now, from an engineering perspective, this is quite simple. Of course, the first picture that I had showed the parts, and the second picture showed a design, right? So it showed how the parts are all fitting together. And if we just look at the parts are, of course, correct, although I see there's two parts here that sort of don't end up in the final design. Okay, so my first year student put in some extra parts that weren't actually needed. I don't think that any were left out. At any rate, I've got parts and I've got a design. And of course, if I look at the design, it sort of makes a lot more sense of what I mean by this orthogonal translation rotational energy transfer device than just by looking at the parts. So now how does this story match up to our research methods? And okay, there it is. The relationship in our research between methods and methodology is quite simple now. The methods are the parts, and the methodology is the design. It's how all the parts fit together. Right, so now, if this is the only thing that you take away from this webinar today, then that's fantastic. Very often I see in research proposals, in final work, I see that these two things, the methods and the methodology, are being confused tremendously. And very often all that is being written down in, say, a research proposal is a list of methods. And the list of methods is being written down completely correctly. However, the methodology is missing. So even though the parts of the research are present, the design of the research is not clear. So now you have to, in your mind, look at all the parts and say, well, what does the researcher actually mean by all these parts and how do they fit together? And of course, that's very challenging. So let's go and look at this a little bit more directly. So here we've got methods versus methodology, and the methods are the ways of doing things. Okay, so sometimes they're called protocols, procedures, standards. It's the actions, the things that you actually do, like taking measurements or building an experiment or processing data or administering a questionnaire. It can be anything that you actually do. It's the actions. And these actions can normally be described quite well. You can really describe exactly what's going to happen, what the steps are that need to be taken. Those are methods. Then on the other side, when we talk about methodology, it's about how the methods fit together, why the method was chosen to begin with, the limitations of the methods, the function of the method, and then, very importantly, how do you know you are not making an error? So methods are the parts of your research. Methodology is the design. How do those parts fit together in a way that makes sense? Right. So in the way that makes sense, a way that carries meaning. Right. So every part is in the right place for the right reason. That is the methodology, and it is built up out of the methods. Right. So folk, you that are listening here, if that is the only thing you take away from this webinar, then that's fantastic. Methods and methodology. A methodology is a design. It's how everything fits together. Right. So I'm belaboring that point, but I think it's an incredibly important point. Now, the next part is, how do we deal with this design? How do we deal with this thing called methodology? So now I'm making the claim that research is about making knowledge, right? And I said so last time and at the beginning of this webinar as well. So research is about making knowledge. And then I'm saying that methodology is the design of the knowledge-making process. Right, so we're going to make this knowledge, and of course we're going to have to do a whole bunch of stuff, so there's a process involved, and methodology is the design of the knowledge-making process. Now, designing processes is something that engineers are quite familiar with, and we do this all the time. So that's not a concept that's strange or unusual. But in designing this knowledge-making process, there are two things that are vitally important that we often don't think about, that we ignore, and it comes back and bites us later on, right? So those two things are, first of all, if we look at the design of the knowledge-making process, we first have knowledge. So we need to know what knowledge looks like. And we can ask some questions. What does knowledge look like? What can be known? What is unknowable, and what is reality? Now, this sounds like something that comes out of philosophy, right? So what can be known and what is reality? This looks like it doesn't really have much bearing on engineering. Don't worry, we're going to look at a couple of examples where these things are going to become immediately visible. as to what I mean by them. So pretty much we want to know over here under knowledge, to what extent can something be known, right? So what is in our reality when we are trying to make this knowledge? The second part is the process. And how do you as a physical person, the researcher, fit into the knowledge-making process, right? So normally you'd like to think that you stand outside of it. And we're going to worry about that. We're going to worry about that quite a lot. And we're going to ask the question, sort of, what is the relationship between the researcher and the researched? Right, these are probably two things that when it comes to your research, you're not thinking about right now, because you just go out and you do it, and you do what is reasonable, and that's okay. But these could be things that you are missing to some extent. Now, to try and make sense of what I've written down here, we're going to look at a couple of examples, real-life engineering research examples, and we're going to just briefly go through them, and we're going to extract what I mean by to what extent can something be known and what is reality, and also how you, the researcher, fits into this process. Now, I'm going to do this quickly because we have to get through a couple of them to build up this picture of where I'm going. So to start with, here's Research Project 1. To start off, Research Project 1 is going to be, here's my research question: how does the heat treatment process affect the hardness of a new metal alloy? Right, so I'm a metallurgical engineer, and I've got this new metal alloy, and I'm going to try and figure out what the heat treatment process does to its hardness. So this sounds like a reasonable research project for a metallurgical engineer, and I can ask, what would the shape of the knowledge be that comes out of that research process? And right now I'm thinking it could be a graph or an equation. So I might have as my result coming out of this, the core result, let's say it's a graph, and that graph is busy showing on the x-axis the temperature of the process, and on the y-axis it's showing the hardness. And I've got some kind of a line on that graph, and that shows the relationship between the temperature of the heat treatment process and the hardness of the alloy. And that might be a perfectly acceptable piece of knowledge, and it could be something that's very useful for folk in metallurgy. And I might also be able to capture what's on that graph in an equation. So that sounds like a reasonable piece of knowledge that I can make. I can state that that knowledge is completely knowable because I've got the equation, and the equation is exact, and I can drop in the parameters in the equation, and I can come up with a hardness, or I can go and look it up on the graph. My knowledge is completely knowable. What is the relationship between the researcher and the knowledge made? I'm saying it's zero. So now, Desmond introduced me earlier today, so I'm going to pick on Desmond, and I'm going to say that if both Desmond and me are busy doing this piece of research, then the graph that we are going to produce is going to be the same. And it doesn't matter if I did it or if Desmond did it. There's no difference between the knowledge that we make and who we are. So there's zero relationship between the researcher and the knowledge that we make. Okay, the metal alloy doesn't react differently when Desmond is working with it than when I am working with it. Okay, so the metal doesn't say, oh, I like Desmond more, so I'm going to be a little bit harder, and I'm going to show better performance when Desmond is working with me than when I'm working with him. So zero relationship between the researcher and the researched. Now, Research Project 2. I'm a mining engineer, and I'm asking, how effective is the safety training program? So I'm working on a mine, and I'm worried about safety. I'm worried about people injuring themselves, and there's a safety training program in place, and I'm asking, how effective is this safety training program? Right, now, what is the shape of the knowledge? I'm saying it's going to be a confidence level, and the confidence level is going to be, I think the training program is excellent, it's reasonable, it's sort of no, it's no good, it's not reaching its purpose. So the shape of the knowledge is going to be a confidence level. Can I say that the effectiveness of the safety training program is known exactly? Can I describe it by an equation? Probably not. probably here I'm going to have to be doing some statistical analysis, and I'm going to say there's a 95% confidence that this training program is effective. Or I might come up with a different result. But the effectiveness cannot be known exactly. Then, the relationship between the researcher and the knowledge being made, is there a relationship between who I am and my result that I get? I'm going to say there's somewhat of a relationship. So let's say, again, Desmond and myself are busy doing this analysis. We're doing this piece of research, and we come from different backgrounds. Let's say Desmond is coming from the background of training, and I'm coming from the background of production. And we need to make all sorts of choices and assumptions during our research. Now, Desmond is worried mostly about the well-being of people and the training of people, and assesses the program from that point of view, and comes up with the conclusion that the safety training program is absolutely wonderful, it's doing a good job, and produces a lot of statistics to demonstrate that. Myself, on the other hand, I'm coming from the background of production, and I'm seeing that the safety training program, yes, it prevents accidents, and that's good, but it has also reduced production to such an extent that we're probably going to have to close down this mine because the mine is just not making any more money. So all of a sudden I say, but that training program is no good. It's not very effective because we're going to have to shut down this mine. So now that's a very extreme example, but it shows that depending on who we are and what choices we make during our research, we can have somewhat of an influence on what that final result might look like. So there is a little bit of a relationship between the researcher and the knowledge made. Right, research project number 3. I'm a civil engineer, and I'm being asked, what are the water reticulation requirements in new urban settlements? Right, so we're building a new suburb where there are going to be some houses where people are going to live in it, and we need to supply some services to those houses, and one of them is water. So we need to put in water reticulation. Okay, that's water, that's pipes, that's valves, all the rest. So we need to give water to these dwellings, these houses, and we need to know what are the requirements that we need to write into the specification so that the contractors can go and install these water pipes. So what is the shape of the knowledge? I'm thinking that might be a system level description or some kind of a design specification. Now, is that knowable exactly? I'm saying that's somewhat knowable. As the engineer, I first need to go and speak to my client. Who is my client? Well, it's the mayor of the town. And the mayor of the town tells me that there's only one requirement, and that is that the people living in that new area must be happy. So my client tells me that happiness is the outcome that is required. Of course, I'm a civil engineer and I know about water. Now I need to translate the requirement of happiness, which is all what my client can tell me, into something that looks like a water reticulation specification. So now, depending on who I am, I'm going to interpret what the customer, what the client, the mayor, what they call happiness, what it means in terms of water. So that's going to be a unique interpretation depending on who I am, because I'm now dealing with a non-technical person, and I've got to try and make sense out of what this non-technical person is saying. The customer isn't wrong. So the customer wants everyone to be happy, and I've got to now come up with a design specification. So it's going to depend on who I am and how I interpret happiness as to what kind of water reticulation system specification I come up with. Right, so the knowledge is somewhat knowable, but it very much depends on who I am. Last project. I'm a production engineer, and I'm asking the question, what is a new production process that can reduce costs? Right, so in my factory, I'm running this production process, and I see that it's just too expensive. The stuff that we are producing costs too much, and I want a new production process that can reduce costs. So what is the shape of that knowledge that comes out of that research project? Well, I'm thinking it might be a process diagram or a factory layout. I need to come up with this new process. Now, in coming up with that new process, I'm thinking it could be that there are almost infinite possibilities, right? I'm saying semi here, but it could be the almost infinite possibilities. I can pretty much come up with a huge number of different factory layouts that will all reduce costs. And if Desmond and I are both doing this, then we can both come up with a factory layout, and let's say they both reduce costs, but the factory layouts might be utterly and totally different. So is this knowledge exactly knowable? Is there one answer that we can point to and say that is the correct answer and all the others are not? I'm saying no. There are extremely large, many possibilities of answers that are correct. So knowledge that is acceptable. And now, what is the relationship between the researcher and the knowledge that is being made? I'm saying it's utterly dependent on the researcher. It's a creative process. We're going to be, both Desmond and I are going to be very creative in coming up with this new production process. Of course, we've got constraints, but we're going to be really creative in it. And our processes are going to be utterly different. And pretty much what comes out of here is going to depend on our experience as process designers. So there's going to be zero correlation between what the two of us produce. So it's completely dependent on the person that's doing the research, what comes out. Okay, so now let's go and take these four and let's go and summarize them and look at them in relation to each other. So we said that methodology was the design of the knowledge-making process, and we said we needed to worry about knowledge and we need to worry about the person in the process. So now here we've got our four different research projects that we were looking at briefly: the alloy hardness, the safety program, the water reticulation, and the production process. And we asked, to what extent is it exactly knowable? So for the alloy hardness, we had that it was exactly knowable, and the exactly knowable extent dropped down to almost nothing when we came to the production process. There we had semi-infinite possibilities. When we look at the influence of the researcher on the process, we see it starts out at zero, and then it gets greater and greater and greater as we looked at these examples. Now, all of these examples are very real, I'm thinking everyday normal engineering research projects. So this isn't something crazy. These are all typical research things that an engineer could be busy with. And we see that the extent that we can get an exact answer is quite variable amongst them. And we can see that the researcher influence is also very variable amongst them. Now, this is how I see, how I summarize methodology from an engineering perspective. At the top here, we have something that could almost look and be at home in the natural sciences, almost physics or chemistry. They have methodologies that predict or that state that everything is fully knowable and it's exact, and the researcher is not involved. As we come down here, we're starting to enter into the region where people are involved, and we're starting to enter into the social sciences, and they have methodologies which deal with researcher influence and the extent to which things are knowable. So here we're looking at the social sciences. And at the bottom here, we are looking at a creative process, and that is sort of art. Now that's bizarre, but yes, we're dealing with art. That's a creative process. So engineering has in its methodology toolkit all of this. Okay, that makes us a little bit more challenging than most other fields, because other fields have rigid rules about how they design their knowledge-making process. In engineering, we cover just about everything from the hard sciences down to art. And probably the research that we are doing doesn't fit exactly into any one of these kinds of descriptions. For example, the water reticulation might indeed be an interpretivist. There I used the word ist. That's no good. It might be an interpretation, so the researcher is involved, but the researcher is interpreting it within the framework of exact science. So water doesn't flow uphill. So even though we might want water to flow uphill, it's not going to happen. And that's what the researcher who's working at this level is thinking about all the time. So what I'm getting at is, in our research and engineering, we very often span multiple domains here. And that is why finding a packaged research methodology in a book or something like that for engineering is pretty difficult, because we span across so many different kinds of research and so many different kinds of knowledge. So my approach to now dealing with research methodology is to ourselves, what is it, and just think back again, what is it that we're trying to do? We're trying to make knowledge. And we're now looking at this knowledge making process and the design of it, and we've seen two requirements: the extent that something is knowable and the researcher influence. Now, we need to take a moment and just step back and understand what it is, where it is that we're working. So now we're going to come back to the slide in a moment, but let's just take a break out and think again about that land of where we have the areas of where we know stuff and where we don't know stuff, right? The knowledge land, the land of the known and the land of the unknown. Now, here we have it. Between the known and the unknown, uncertainty is all around you, and the enemy's name is error. Okay, there's the error monster. The enemy's name is error. Error is always present in the land between the known and the unknown, right? And what are we doing in this area between the known and the unknown? We're busy making knowledge, and we're using a process to make knowledge in that area. And what's going to happen with us? We are going to encounter error, and we're going to encounter error all the time. And the moment you think the error isn't present, then you are fooling yourself. It is. You're just ignoring it. And if you think there is no error at all in your work, then remember, if there's no error, you're in the wrong place. Okay, there has to be a lot of error monsters in here for it to be worthwhile to be working in here. If there's no chance of error happening, then you're probably in the land of the known. Right, so error is the enemy. Getting back to our methodology. This slide summarizes everything that we've talked about now this afternoon. Methodology is our design of the knowledge-making process. In doing so, in other words, in this knowledge-making process, how do you know you are not making an error somewhere, right? We now understand the nature of knowledge, and we understand the nature of how we influence it. In our process that we are going to design, right, how do we know we are not making an error somewhere? That is the core question to be asking when you put together your knowledge-making process, when you design your knowledge-making process. If you think you are not making an error, then probably you are not dealing with research. Because research is about finding that knowledge and eliminating error. And if you don't consider error, it means you're not dealing with research. The defenses against our error is argument, reasoning, and critical thinking. Now, we're not talking about that this afternoon, but argument, reasoning, and critical thinking are the tools we have to avoid that error, and they are huge, and we need to understand them completely. Okay, but we're not talking about them today. We're talking about methodology. So, folk, what I've given to you this afternoon are some insights into this thing called methodology. There's lots written by other fields of study on methodology. And you can find books on methodology, and you can find articles on methodology all over the place. Very rarely, somehow, do you manage to find a book on engineering research methodology. And that's because it's so difficult to pin down. And even if you do find a book on engineering research methodology, when you look inside it, it's normally normal research methodology. It's got nothing to do with engineering. And why is that? It's because engineering covers everything. That makes us a little bit more difficult that makes it a little bit more difficult for us to design that methodology, but it also gives us a lot of freedom because we are able to select bits and pieces from other people's design processes, and we can create our own knowledge-making process. And what I've done this afternoon is give you a little bit more insight so that when you are trying to find your way around your own methodology, you can maybe do so with a little bit more confidence and a little bit more understanding of what it is that you're doing. So in your research, first of all, realize that your methodology is not about a method. Methods are going to be important, and you're going to have a lot of them. But your methodology is the design, how everything fits together. And then keep in mind the knowledge will have some knowableness, right? Either it's going to be exact or it's going to be sort of totally not exact. And you, as a person, are going to have some influence in what that knowledge is that's being made. And you need to understand that. And together, these two things just ask to be made. It is huge, and it is error is really, really, really a big deal when it comes to the knowledge-making process. And your design of that process needs to eliminate that error, and you need to avoid it and find it and track it down and get rid of it everywhere. So, and of course, your defenses are argument, reasoning, and critical thinking. Those are surprisingly, even though I say every field has its own view of what is research and what methodology is, sort of all fields have the same ideas on argument, reasoning, and critical thinking. So we are okay there because every other field thinks about argument and reasoning and critical thinking in the same way that we do as engineers. So folk, that's what I have for you this afternoon. I hope this has given you a little bit of an insight into what's going on, and this is something to reflect on, how this impacts on your own research process and how you are designing your own process to make your knowledge, and how you're avoiding errors in your own way. And folk, if there are questions, I can absolutely engage with questions. I'd be happy to do that, and I'd be very excited to hear what anyone has to say.
Thank you so much, Prof. This is great, and this actually speaks to what you talked about the other time when you were talking about research, and you talked about we, the people conducting the research, should become the deliverables. Please, folks, are there any questions for the good professor? This is the time to ask them. You can just click on the icon that says you want to raise your hand, or you can put the questions in the meeting chat. I see a hand.
Yes, I can see it. Oh,
okay, Prof.
Desmond,
you can moderate.
do you want me to just jump in and have a look at that? I can see the question. So the question we have there is, if research is performed by two people on the same population, can the research outcome be different due to research influence? And I'm going to say absolutely, although it would very much depend on the question that's being asked. I could be asking a question that is exactly knowable on that population, and then we should both be getting exactly the same answer. But if I ask a question and that question is not exactly knowable, for example, we have a population, and we have a question on the population which says, what is the average age of the people in the population? Then that's something that is exactly knowable, and no matter who is asking that question, we're going to get an exact answer, and the researcher influence there is zero. But we might ask a question that requires interpretation. So we might want to ask a question of, are people happier under lockdown conditions than before lockdown? So now that would depend very much on our definition of what do we mean by happiness, and how we might interpret that. and that will depend on the researcher. So we would definitely, I would expect, to get completely different kinds of results, both of which might be actually perfectly valid, because the researchers are coming from different angles on that same population. Right, then we have another question. What could the engagement or involvement and support of supervisors be at the methodology step of a research? Okay, so we can talk a great deal about the role of the supervisor as well. The one thing that I would expect from a supervisor is that a supervisor is normally a knowledgeable person in the field, right? So if you're a metallurgical engineer and you're looking at hardness of alloys, then I'm thinking your supervisor is knowledgeable about alloys and that kind of work. And they are knowledgeable about what kind of methodologies are typically used in the research process, because they're knowledgeable, they're experts in that area. So I would say the supervisor could certainly advise on what is typically done and direction in which to move. So I certainly don't think a supervisor should ever be giving instruction, but they certainly would be able to advise on what are the kinds of methodologies that are normally applied in that area, and sort of guide in the direction of what would be a good methodology to employ. And again, remember, the methodology is a design, and all designs are slightly different. So it could be that the requirements of your research project need a subtly adapted design of a knowledge-making process. So you can't just use the one that the previous researchers before you used. Why? Because there's something a little bit different about your research approach. So that's what I would say is the role of the supervisor at the methodology stage of a research, is actually to say what is typical in this field and guide you along. So certainly what I think a supervisor should be doing is, if you are going in totally the wrong direction, is to say, whoa, wait, stop, come back. That's like going nowhere. So the supervisor normally should prevent you from going over a cliff, but they shouldn't actually be holding you by the hand and guiding you along step by step. Right, then we have another question. Is the relationship between extent of knowledge and researcher influence always inverse like this? In other words, does more exact knowledge always relate to zero influence from the researcher? That's a good question. That's a very good question. I've drawn it like this because this is how it came out. I would almost like to think, and I'm guessing now, I'm going out on a limb here, I would like to think that yes, it is. But we must be cautious. So pretty much what I mean by the extent knowable, and so in other words, is there a single exact answer? If there is a single exact answer, then it means no matter who is doing this work, they have to get to the same answer. So that means there is by definition zero influence. Although maybe further on down that list, sort of when we come to the creative processes, it could be that in a creative process, let's say you're designing the production process in the factory, that sometimes the constraints are very dominant, and that limits what you can actually achieve in being creative. And then it could be that what I call semi-infinite possibilities is actually sort of pushing in a direction which limits the amount of possibilities if our constraints are large. And it could be then that multiple people sort of tend to come up with similar kinds of solutions. So I wouldn't necessarily say that it's exactly inverse as I've drawn it here, but that's my feeling right now, that we're moving in that direction. Okay, so but that's a good question. I need to think about that more deeply. Right, then we've got another question. How do you know as a researcher if you have influence, and how do you measure the extent? Okay, how do you know if you have influence? Well, pretty much you ask, to what extent is my research, the outcome of my research, to what extent is it exactly knowable? In other words, if someone else had to do this, would they come up with identically the same thing? And if the answer is yes, then you know that you have zero influence. Okay, so you have to actually just do the research. Then you're sort of in the physics realm, or the chemistry realm, the realm of the natural sciences, where the outcome of your research doesn't depend on you. Right, so you can ask, to what extent would someone else, to what extent could someone else come up with a different solution here, or a different answer, or a different outcome? How do you measure the extent? Yeah, that's a good question. I'm not sure it is necessary to have an exact answer to the extent to which you influence it. Right, so of course the extent to which you influence it means how variable are the set of answers that can come out of here. And my feeling is on that, you wouldn't need to measure that extent exactly, but you'd need to know it exists, and you need to know it's a large extent or a little extent. And the reason I say that is because the moment you are influencing the outcome of your research, you need to worry about all the things that you could be doing wrong as a human, in your mind. Okay, so we're not talking about all the biases that come in from the human brain, but as a human being, you've got a huge lot of biases biases and preconceived ideas in your mind, and that influences your research greatly, and it introduces error. And that's normally what you want to avoid and eliminate. When I talk about how do you know you're not making an error, if you can influence the research, then often the error that you are making comes from your own biases that are inside you as a human being, and we all have them. So pretty much that's what how I would answer that question. Know that you have somewhat or to some extent influence on what the outcome is, and then say, how could I be getting this thing wrong? How could I be messing this up? Because I'm a human being and I'm making an error somewhere. Right. Then we have a question. Will all engineering combine all of these realms, or can a research be focused on a realm? And are there preferred realms for engineering research? So the short answer there is, I think you could be working in a realm where you only have one of these things going on, right? So certainly the alloy hardness is a very much closely linked to the natural sciences, and you can very clearly see the links between it. And sometimes you could say this piece of research, if you had to read it, you'd say it could easily be at home, say in another faculty. It could work, it could be okay, let's say in the science faculty, but you're in the engineering faculty, but the nature of what's happening is similar. Okay, so there's another long discussion on what's the difference between science and engineering, and we're not going to get into that right now. But it could be that you are, as a researcher, you're in one of these realms, and you can borrow the methodology from another faculty, from another domain, and you can use it and apply it directly. Now, if you can make that call and say, yes, it is true that I'm only in this one realm, then that's fantastic. Then you can borrow what's been written about research methodology from another place, and you can make use of it exactly directly. Now, is there so you certainly aren't crossing all of these things all of the time. Then a follow-on question from that is, are there preferred realms for engineering research? I'm almost going to say that No, there isn't. Engineers stand slightly apart from the rest of the world, and I'm saying this very cautiously now. But engineers and engineering research has a requirement of, in the background, when you strip away everything, there's a requirement from engineers of, does it work? Okay, so no matter what we're doing in the background somewhere, there's that question, does it work? And it's only engineers that pretty much have this burden on them. If you look at the social sciences, at the natural sciences, there's no burden on them of does it work. They're normally trying to describe the nature of what is out there. However, the engineering field is about pretty much coming up with stuff that works. So our research is always focused on does it work, and the does it work part is in the background, and that makes us makes our research a little bit tougher than the rest because of that requirement. So not only must we avoid error, we must also be sure that it works, and that it works part also gives us freedom, the freedom to cross these domains however we want, because at the end of the day, if we can point out that it works, then but we have violated the rules of, say, the one kind of research methodology or another kind, but we point out that it works, and we've combined things in a weird way that the purists of those research methodologies would absolutely be horrified at, but we point out that it works and we haven't made error, then it's okay. So that it works saves us from everything, but it also puts an extra burden on us. Right, so that's my take on it, and there's a long discussion behind that as well. But and that's what makes engineering different from some of the other fields, is that it works part. Okay, I tend not to want to limit myself anywhere in these domains, and I'll cross them at will wherever is needed, as long as I can say at the end that it works. Then we have another question. Research methodology can be outlined as a series of logical steps from the land of unknown to the land of the known, or vice versa. Is it an exact science, or is it okay to get lost for months without any deliverable? Okay, that sounds completely normal. This research methodology, okay, so this process of making knowledge is definitely not ever a set of logical steps, and even though it's often written down as a set of logical steps, believe me, it's seriously not. And I don't think there's any researcher anywhere that has ever had a very nice linear process of writing down a question, collecting data, processing data, writing it up, and saying I'm finished. I don't think that happens anywhere. And if it was that simple, I almost think it wouldn't be worthy of calling it research. So if you are getting lost for months without any deliverable, of course that's not a good feeling, and you'd like that not to be happening. And I say it's not unusual. Yeah, okay, that's terrible. I'm saying it's not unusual for this to be happening, and it's not nice. It's certainly not nice. So you are drifting around in the land of between the known and the unknown, and you don't know which direction to, and you can't go forward, you can't go backwards, you don't know what's happening, and there's nothing coming out of this. That, of course, is not a nice feeling. What I would say is, if you find you are in this situation for months, then before the months become months, let's say after 2 months, you want to at some point just put up your hand and say help, and look around you and try and make sense of where you are. So if you are going around in circles for months, sometimes what you need is someone just to push you in the direction to get you out of the going around in circles part. So we're not talking now about the actual, let's say the planning of research, because you can design the process, but then you've got to execute the process as well. We're not talking about that right now. But the one thing that irritates me tremendously when I read books about writing a dissertation or planning your thesis or getting a paper out, they all talk about this very nice linear progression. And you sort of start and you do the one thing and the next thing and the next thing, and then you're finished. And you can write your thesis in 21 weeks. And those kind of books, when you read them, they all sound so easy. And it sounds like, oh, I can do this 21 weeks and I got my thesis out. And when you try that, of course, it just totally doesn't work. And those books are very misleading. So don't read that kind of book. The actual execution of this process is very nonlinear, and you're going to be going around in circles a lot. So it's not nice. It's not a nice feeling. And you don't want to be going around in exact circles. You want to make the circles go a little bit wider or narrower, or you want to try and break out of that circle. But okay, we're now drifting off from the methodology side of things. But certainly it's not a linear process. Right, we have another question. What is the expected level of the knowledge-making process? Okay, so what is the expected level of the knowledge-making process relevant to a master's? Okay, so now as a researcher, you are making knowledge. That's how we defined knowledge, or how we defined a researcher. And of course, at the PhD level, you're doing research. At the MSc level, you're doing research. And it could be at an honors level, you also might be doing a piece of research as well. And what I'm going to say is that the nature of what you are doing remains exactly the same. So whether you are making a little piece of knowledge or you are making a huge piece of knowledge, you're still in that land between the known and the unknown, and you still have to find your way, and you still have to deal with the uncertainty, and you have to deal with the error monsters. So to now perhaps state this in a simple way, I would say that when you are busy with your masters, you are a junior knowledge maker. And when you are busy with your PhD, you're a senior knowledge maker, right? So I would split them apart like that. Now, sometimes people will say that a master's doesn't need to make a contribution, and then I'll ask the question of what is a contribution, and a whole bunch of stuff, and it's very difficult to pin down what they actually mean. So that's why I don't like going in that direction. Because it very much depends on interpretation. I'm going to say that a master's research is about becoming a junior knowledge maker, and then the PhD, you're a senior knowledge maker. So you can sort of go in much more boldly into that area between the known and the unknown, and you can knock down those monsters. You can knock down those big monsters that are in the way, preventing us from gaining new knowledge. But whereas a master's student, you're at a slightly more junior level. So that's how I interpret the differences between the PhD and the MSc. Although there's a lot that we can chat about as well when it comes to what is a contribution, but okay, that's maybe for later. Then we have another question here. Using what is known in another environment to find what is known in a different environment using the same principles applied in the known environment, would it be considered as research? Okay, that for me to just rephrase that question, I'm thinking that what that question is asking is, can I take a tool from or a process or a procedure, a method in other words, from one that is commonly used in one field and it's not commonly used in my field? Can I borrow that method and apply it to a problem in my field and see what comes out? So I'm thinking that this is to some extent interdisciplinary work, and certainly by employing a new tool in your field, you might see things and you might be able to build knowledge that previously wasn't possible. So, for example, something that's hot all the time is computational computational intelligence, that's the neural networks and the machine learning and all the rest, that kind of computational intelligence sits at home in the field of computational intelligence, and you can use that computational intelligence to solve all kinds of complex problems. Now, if you are in a different field, let's say you're in the alloy hardness field, and you're trying to design a new alloy, and you are confronted with a whole bunch of data, and it's difficult to make sense of this data. And what you would normally do is you would normally just choose one of these data points, and you'd interrogate it. And you choose that data point at random. Now, if you had to take one of the computational intelligence tools and employ it in your field, you might find that you no longer need to go through a huge number of experimental work on a semi-random basis, because that computational intelligence tool can sort of point out a sensible direction in which to move. So now you are taking a tool from the one domain and applying it in another domain. And certainly, I think that can produce a good piece of research. So that would count, I think, very much as research. Okay, so there's another webinar we can have one day about what makes a project really research worthy. And we can almost say what makes a project research worthy is that the uncertainty in the outcome is large. Because if the outcome is certain, then it's sort of obvious. And then you don't really need a researcher to do that. So I would say if you are using the tool from another domain in your domain, and you're coming up with a result, then I should say that the use of that tool shouldn't be obvious, and it shouldn't be giving obvious results. If there is uncertainty and you have to deal with that uncertainty, then I'd say certainly it's a valid piece of research. Right, folk. Aha, excellent. I think we've run through a whole bunch of questions. We have one more. Here we have it. If pre-existing methods are known in exact cases and reduce error, does the methodology restricted by the existing methods contribute any error other than an error on control variables? Okay, let me just think carefully about what that means. I'll read it again. If pre-existing methods are known in exact cases and reduce error, does the methodology restricted by existing methods contribute any error other than error on control variables? I'm worried about my understanding of that. I might be missing that. So what I'm saying here, or what I'm reading here, is we've got pre-existing methods, okay, ways of doing things, and we know that they work, right? And now we're using those existing methods in a certain way, and we're asking the question, how do we control for error? I'm not sure I understand this question. Okay, so I'm seeing Jean or John. I'm not sure I'm following your question completely here. We could have existing ways of doing things, and we could employ them again in our own work. That's good. And if the ways of doing things are known to give good results, so they're known to give exact results, we could maybe even say there's a measurement standard with exact ways of going about doing things, and we employ that, then of course we have the safety of avoiding error because we're following a known procedure. I would just say that remains a method, and it would still need to be incorporated into a bigger methodology, into a design. And even though we're executing that method in a very fixed way, we could still have the result coming out of that method as being not sensible for the bigger picture. So now we need to worry about that bigger picture, about the design of the entire process. So here we have Here we have someone saying, I'm using a known principle in chemistry to solve a problem on a transformer insulation, even though I'm making a lot of modification on the material characteristics to fit and solve my problem. So sure, you're using a known principle, and absolutely use that principle. We might even say that that principle is based on some theory, and the theory is well known and well accepted, and there's almost zero chance for error while you are using that method or that principle. That's good. But you still have to make it fit into the research problem that you are busy dealing with.
Okay.
Okay,
Hello.
folks. So we are. I think we are done for today. I see we have gone 7 minutes over time. We are sorry for that. But folk, yes, from my side, thank you very much for being here, and thank you very much for taking the time to listen to what I have to say. So Desmond, I think that's me for today. Thank you for inviting me.
Thank you so much, Prof. And we really appreciate your time and the incisive presentation that you gave us today. We are really grateful to have you. Folks, yes, we are done for today. I would email you the whole evaluation survey so that you can evaluate this once. And like Prof alluded to earlier, if you have specific topics that you want us to treat, we will do so. The purpose or the nature of these webinars is to force us to think so that we can challenge conventional wisdom. I'm told that in this era that we are in, we have a lot of students that have well-filled minds instead of well-formed minds. So the idea is that through these webinars, we can challenge our own thinking and try to do something that is worthwhile. We thank you all for coming. And once again, I just want to thank all my colleagues, Mike, Tabatupala, Mahlati, and the entire team for doing this one. We will send the recordings to you, and watch out for this space as we bring you webinars going forward. We're looking to make it more exciting, more attractive. So please, you are welcome to email me or email aid.edu@wits so that we can look at it and then tailor the webinars to your very needs. Thank you so much and have a wonderful evening. I thank you. Bye.
Thank you, Desmond. Bye-bye. Bye-bye, everyone.
Thank you. Bye.
Thank you. Bye.